Hi everyone, my name is Darcy, and I'm a software engineer here at Google. I work in cloud and help write problems for coding competitions. We hope you had a blast competing this year. Today, Sherry and I are going to talk you through the problem Hexacoin Jam from our final round. Sherry, why don't you go ahead and introduce yourself?
Hi everyone, my name is Sherry, and I'm a site reliability engineer at Google. I work on making sure that Google stays up and running, and I help write problems for coding competitions in my 20% time. As Darcy mentioned, we will be talking you through what Hexacoin is asking and how you might go about solving it. Remember, you can always try any of our problems on your own at any time in practice mode on g.co/codejam. Now, let's get started.
Hexacoin is CodeJam's newest cryptocurrency. Just like normal cryptocurrencies, you need to mine the coins. However, the way you mine a hexacoin follows a rather strange process.
First, you are given a list of numbers. Each of these numbers is written in base 16. Normally, numbers are written in base 10 using the digits 0 through 9. In base 16, the numbers are written using the digits 0 through 9 as well as A through F for 10 through 15 respectively.
To successfully mine a coin, you must pick two numbers from the list, shuffle their digits, and add those two numbers together. If this sum is within a specific range, you have successfully mined a hexacoin.
Now, what do we mean by shuffle their digits? Well, you will randomly choose one of the 16 factorial permutations and permute each digit in all numbers by that permutation. For example, if we have this permutation, all zeros will change to 3s, all 1s will change to A's, and all C's will change to 5s. So if the original number is 0C50, this will become 35B3.
Cool. So now that you know how to shuffle the numbers, let's remind you again about mining. To mine a coin, you will choose two numbers from the input list, shuffle their digits in the way that Sherry just described, and check if this sum is between two values, X and Y. In this problem, we'd like you to compute the probability of successfully mining a coin, assuming you just randomly select a permutation and randomly select a pair of numbers from the list. Good luck mining out there.
So how do we go about mining, Darcy? Can we just count the number of valid pairs one at a time?
We could, but because we're using base 16, there are 16 factorial permutations to consider. Even just generating those will probably take too much time, let alone counting the number of pairs. I think we'll need something a little faster.
How about we think about the simplest case for this problem? That's when the range has just one element in it. So we need to permute the digits and find pairs of values such that their sum is exactly some value k. Let's consider all possible ways to sum to k. So there's 0 plus k, 1 plus k minus 1, 2 plus k minus 2, and so on. For each of these, let's look at their digit structure. Any pair of numbers that has the same digit structure can be permuted in some way to get us to this pair of values.
I think you're onto something there, Sherry. So if we have k equals 1442 plus 1287, this has the digit structure of xyyz plus xzvu. Note that digits that appear in both the first and second number need to use the same digit in their digit structure. Now, any other pair of numbers that has the same digit structure can be permuted to our desired pair of values. So, for example, the pair 4991 plus 4102 has the same digit structure as our original numbers.
Exactly. So any permutation that maps 4 to 1, 9 to 4, 1 to 2, 0 to 8, and 2 to 7 will map 4991 plus 4102 to 1442 plus 1287. How many permutations are there that do that? Well, there's 5 digits that we need to fix, and every other digit can be anything we want, so there are 11 factorial different permutations that map 4991 plus 4102 to 1442 plus 1287.
Okay, that's really neat. So we can use this to solve our problem in 2 steps. First, for every possible way to sum to k, that's 0 plus k, 1 plus k minus 1, and so on, we'll store those digit structures. Then, as a second step, we'll pair up all of the numbers from our original input and compute their digit structure. For each of these digit structures, we count how many times that digit structure appeared in our first step and add the appropriate factorial to our answer.
The solution to the full problem requires a small change to that, but for the simplified version with a range of size 1, that works. We won't go through the details of the full solution here, but as a quick hint, think about chopping off digits from the end of the digit structure to represent some sort of range.
Make sure you check out the full analysis on g.co/codejam. You can also try solving any of our problems at any time in practice mode on our site as well. Thanks for watching.